The engineer's LinkedIn post was just 3 sentences long. No fanfare, no press release, just a quiet technical note about a chip he'd helped prepare for manufacturing. Within hours, it was gone, deleted without explanation. But it was already too late. The Korean tech press had copied it, and what those 3 sentences revealed quietly shook the semiconductor industry to its core. Because buried inside that post was confirmation that something Elon Musk had been pushing for years, something critics called overambitious, impractical, maybe even delusional, had just crossed a point of no return. Here's the number that started the conversation. Tesla's Optimus robot costs around $10,000 to manufacture. Musk plans to sell it for around $20,000. That's a 100% markup. Scale that to hundreds of thousands of units, and you're looking at billions in profit. Scale it to the millions Musk says he wants to produce, and you're talking about a company-level transformation that would dwarf anything Tesla has done with cars. But none of that math works without solving one critical problem first: the brain. The chip that runs Optimus's artificial intelligence is the single most important component in the entire robot. And for years, the question hanging over the whole project was whether Tesla could actually build one powerful enough to make Optimus genuinely useful, while keeping it efficient enough to run on a battery the size of a laptop's. That LinkedIn post answered the question. The engineer who worked at Samsung confirmed that Samsung had completed what's called a tape-out of Tesla's AI-5 chip. Now, that word tape-out comes from an era when chip designs were physically shipped to factories on reels of magnetic tape. The process is digital today, but the term stuck. A tape-out means the design is finalized, locked, and handed off to the manufacturer. Think of it as signing the blueprints before construction begins. After that point, nothing changes. You build. Here's where it gets interesting, because there are actually 2 tape-outs in this story, and that's where a lot of the confusion comes from. Back in April, Musk celebrated the first one publicly, announcing that Tesla had finished designing the AI-5 chip. The architecture was complete, the internal design was validated. What Samsung just confirmed is the second tape-out. Before a chip foundry can actually produce a processor, it has to adapt the customer's design to its own specific manufacturing process, its own machines, its own physical constraints. Tesla's design was ready in April. Samsung's factory is ready now. And it's not just any factory. The AI-5 chip will be manufactured in Taylor, Texas, on Samsung's most advanced production line. Nobody in the industry saw that coming. The prevailing assumption until this week was that Samsung's most cutting-edge process would be saved for the next generation, the AI-6, while AI-5 would run on an older, more established node. The deleted LinkedIn post blew that assumption apart. AI-5 is being built using a transistor architecture called gate-all-around, where the gate of the transistor wraps around the conductive channel on 4 sides instead of 3. It's a more 3-dimensional design, and it delivers meaningfully lower current leakage and better energy efficiency. For a chip that has to run inside a robot powered by a small onboard battery, that's not a minor technical footnote. That's the difference between a lab prototype and something you can actually mass-produce and deploy in the real world. The contract between Tesla and Samsung for this work is worth $16.5 billion, signed last year. If the timeline holds, the first AI-5 chips will come off that Texas production line relatively soon. Now, why does this chip even exist? For years, Tesla designed processors to drive cars. That was the core mission. AI-5 breaks completely from that logic. Musk has said repeatedly that the current chip, the AI-4, already has enough processing power to make autonomous driving safer than a human driver. The driverless robotaxis currently operating in Texas and Miami seem to back that up. If AI-4 is sufficient for driving, Tesla doesn't urgently need AI-5 in its cars. So AI-5 is aimed at 2 bigger targets: Optimus and the supercomputers used to train Tesla's AI models. Here's the counterintuitive part. A humanoid robot actually needs more computing power than a car. When a car drives, its environment is relatively structured, roads are marked, traffic laws are consistent, rules are clear, even if not everyone follows them. A humanoid robot operates in a completely different kind of chaos. Today it's a factory floor, tomorrow it's a warehouse. Eventually it's your living room, it grabs objects, it navigates around people. It responds to situations that change constantly and unpredictably. The volume of computation required to manage that complexity is significantly greater than what's needed to drive on a highway, and that creates the central engineering problem. More computing power typically means more energy consumption. Optimus carries its own battery, roughly 2.5 kilowatt-hours. Compare that to a Model Y, which carries around 75 kilowatt-hours. The robot's battery is drastically smaller. If the processor consumed 500 watts or more at full load, it would drain a massive share of available energy before the leg motors even engaged. You'd have a highly intelligent robot that goes flat in half an hour. Tesla did what it does best. It optimized aggressively. Recent reports indicate AI-5 now consumes around 250 watts. That reduction is the difference between a robot that needs to recharge every couple of hours and one that can run a full 8-hour shift. That's the line between a novelty and an actual industrial tool. How did Tesla get there? By cutting everything that wasn't essential. Most processors include a graphics processing unit and an image signal processor, components that handle gaming, photo editing, video display. Tesla doesn't need any of that. Engineers strip those blocks out entirely and replace that freed up space with hardware dedicated to one single task, running Tesla's AI inference software. Every transistor on this chip exists to do AI and nothing else. The result is a chip that delivers around 2500 TOPS of computing performance with 144 gigabytes of memory per chip. Roughly 3 times the capability of the current dual AI-4 system. Musk has said that solving AI-5 was an existential task for Tesla. He reportedly spent every Saturday for several months working directly with the engineering team on the chip's architecture. Whatever you think of Musk personally, betting against him has historically been a losing position. When he starts sacrificing his weekends to work on processor design, that tells you something about where the company's priorities actually are. Tesla is also not relying on a single manufacturer. AI-5 will be produced simultaneously at Samsung and at TSMC, the 2 largest chip foundries in the world. The versions coming out of each factory will differ slightly, since each foundry translates a design into physical silicon differently. But Tesla's software will run identically on both. That's a deliberate hedge. If one factory goes down, if yields become a problem, if geopolitical tension between Taiwan and China escalates, Tesla has a fallback. The strategy extends further. Samsung will take exclusive responsibility for the next chip, AI-6, while TSMC will manufacture AI 6.5. Tesla is building 2 parallel supply chains for its most critical components. While Samsung prepares the silicon, Tesla is simultaneously converting the factory that will use it. The company published a video showing construction equipment tearing out concrete trenches, dismantling robotic arms, and clearing out the assembly line that had built the Model S and Model X for 14 years. All of it done in 46 days. The Model S was the car that forced the entire automotive world to take electric vehicles seriously. Tesla just demolished its birthplace to build robots in its place. Limited production of the next generation of Optimus is set to begin at that facility in the coming weeks, with a target capacity of 1 million robots per year on that first line alone. A second line under construction at another Tesla facility aims for 10 million per year. Musk has acknowledged that the ramp will start slow. Optimus contains around 10,000 unique parts, and the global supply chain for humanoid robotics, frankly, doesn't really exist yet. It will have to be invented alongside the product itself. AI-5 is just one step on a much longer roadmap. AI-4 currently powers Tesla's vehicles and robotaxis. AI-5 pushes that capability further while giving Optimus the processing power it needs to be genuinely autonomous. AI-6 is positioned to push Optimus even further, and then there's AI-7 through, which is where Musk's vision shifts into a completely different dimension. The long-term plan involves embedding Tesla's AI hardware into satellites, where solar energy is essentially unlimited and ideal for running massive AI workloads. It sounds like science fiction. Then again, so did reusable rockets. To support all of this, Tesla, SpaceX, xAIs, and Intel are reportedly collaborating on a massive facility in Texas, a manufacturing complex spanning roughly 9 million square meters. The stated goal is to produce 1 terawatt of computing power per year. To put that in perspective, that's double the current total electricity consumption of the United States. The scale being targeted here is almost incomprehensible. Now let's be honest about the timeline. Engineering samples of AI-5 aren't expected until late next year. Volume production likely won't begin until mid-2027 at the earliest. Tesla needs hundreds of thousands of completed AI-5 boards stockpiled before it can switch over its production lines. This tape-out comes nearly 2 years after Musk originally promised AI-5 would be in vehicles. The Cybercab is launching on AI-4 hardware. An intermediate chip quietly slipped into new Model Y units before AI-5 arrives. Musk's timelines are almost never accurate. His directions, however, have a strong track record of eventually becoming real. He announces things far too early, but they tend to happen. What's unfolding here is bigger than a chip announcement. Samsung is preparing the silicon. The assembly facility is being converted. 2 industrial processes on 2 different continents are converging on the same product, the brain and the body of the same robot being built in parallel. The iPhone didn't change the world the day Apple filed a patent. It changed the world the day a manufacturer figured out how to produce millions of them on an assembly line. We are at that moment for humanoid robotics. The chip is designed, the factory is being cleared, the timeline is tight, but it is real. If you want to stay ahead of where this is all heading, hit subscribe and leave a like. It genuinely helps this channel keep covering the stories that actually matter before everyone else catches up.